Assalamualaikum warahmatullahi wabarakatuh. Hi, I'm Siti Norhuda. In this video, I'm going to explain about the membrane process for wastewater reclamation. What is wastewater? Wastewater is used water that has been affected by domestic, industrial, and commercial use. The composition of wastewater is 99.9% water and the remaining 0.1% is what is removed. This 0.1% contains organic matter, microorganisms, and inorganic compound. As clean water is needed globally, we need to treat the wastewater. What is the reclaimed wastewater? The circulation of water through the natural water cycle can be short-circuited, such that a contribution to human water needs is made and the environmental impact thereof limited. Furthermore, a main characteristic of reclaimed wastewater is that its production is relatively constant during the year, due to its source being dependent not on rainfall, but on the production of municipal sewage. So, how can we produce the reclaimed wastewater? By membrane filtration. Membrane filtration is basically a modern physicochemical separation techniques that use differences in permeability as separation mechanisms. During treatment, water is pumped against the surface of membrane. Now, let's look into the type of membrane processes. There are 4 types of membrane processes, which is the first one is the microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. Microfiltration has quite bigger pores compared to the reverse osmosis, which has the tiniest pores on its membrane or surface. Let's look deeply into each of the process. Let's begin with the first one, microfiltration. Microfiltration is the membrane with a pore size of approximately 0.03 to 10 microns. It has low feedwater operating pressure of approximately 100 to 400 kilopascal. The application of microfiltration is to remove sand, silt, clays, guardian lamp, Cryptosporidium cyst, alga, and some bacterial species. It combined with the disinfection to remove viruses. Because microfiltration cannot remove viruses itself. Microfiltration also removes natural or synthetic organic matter to reduce fouling potential. It also requires pre-treatment to increase the removal of organic matter. Microfiltration can also act as pre-treatment for reverse osmosis and nanofiltration to reduce fouling potential. Let's move to the next process, which is the ultrafiltration. Ultrafiltration is the pressure-driven separation of materials from water using a membrane pore size of 0.002 to 0.1 microns. Its operating pressure of approximately 200 to 700 kilopascal. The application of ultrafiltration is to remove all microbiological species, which is removed by microfiltration, and some viruses, which is not absolute barrier to viruses and humic materials. The combination with infection provide a second barrier to contamination and recommended. The third process is the nanofiltration. Nanofiltration basically has the nominal pore size of approximately 0.001 microns and an MWCO of 1000 to 100,000 daltons. The operating pressure are usually near 600 kilopascal and can be as high as 1000 kilopascal. The application of the nanofiltration membrane is to remove virtually all cysts, bacteria, viruses, and humic materials. It also operates on the principle of diffusion rather than sieving as with microfiltration and ultrafiltration membrane. Nanofiltration also removes alkalinity, hard water treated that needs pre-treatment to avoid the precipitation of hardness ions on the membrane. However, nanofiltration needs more energy to operate the membrane. Next one is the reverse osmosis, Reverse osmosis removes contaminants from water using a semi-permeable membrane that permits only water and not dissolved ions. It efficiently in removal of radium, natural organic substances, pesticides, cysts, bacteria, and viruses. The contaminated water is subject to high pressure, which forces pure water through the membrane, leaving contaminant behind in a brine solution. Reverse osmosis is particularly effective when used in series. In conclusion, membrane has been the key component in wastewater treatment with different pore sizes of each layer of function and reclamation nowadays, and its contribution can be contribute to conventional water treatment process. That's all from me. Thank you.